In this video, we are going to continue doing operations with rational exponents. This time we have some variables involved, and we are going to focus on when to add our exponents, when to multiply our exponents, and also when to subtract them. So this is connected to something we've done in the past. Here we have a power to another power. So we are going to multiply those exponents. And since they are fractions, we do want to remember that when you're multiplying fractions, essentially you're just going straight across. So it ends up being 1/6. So my final answer here is going to be x to the 1/6. In this second example, since I'm multiplying things that have the same base, we are going to actually add our exponents together. These exponents are fractions that do have the same denominator, so I don't have to do a whole lot of work there. I can just put the 1 and the 7 together and get x to the 8/4. But just like any fraction, whenever I want to try and simplify as much as possible. And 8 divided by 4 is 2. So that is my final answer for that one. Let's look at a few more examples. Again, I'm multiplying the same base here, but this time my denominators do not match. So I do have to do the work for that because in order to add those together, I need the bottom to be the same. So I'm going to go with 15 on both of them. He's going to become 3, 5. Okay. So this is going to be x to the 8/15. So you do have to still know how to deal with your fractions. Of course, you can use your calculator to help you find the common denominator and convert. In this second example, we're going to be subtracting exponents because it's division. So we're going to go top minus the bottom. The exponents do match already, the denominator, so I'm okay with that. So I can go 1/4 minus 3/4, which is going to give us a negative 2/4. So I'm going to have x to the negative 2/4. I can simplify that to be x to the negative 1/2. And we don't usually like to leave our answers with a negative exponent. So we are going to go ahead and push that down. And that will be our final answer for that one. We're going to keep going here. Sometimes it benefits us to take radical expressions and convert them to rational exponents so we can actually put them together. Because as is, I cannot do this problem. The indexes are different. So it might be in my best interest to convert these back. So if you remember before, the index was the denominator. And technically there's a 1 here. So this converts to x to the 1/3. And this is my denominator for this one. So this becomes x to the 1/4. Now that I have them written as rational exponents, I can find common denominators for them and put them together. So I'm going to have 1/3 plus 1/4. My denominator becomes a 12 here. So I end up with x to the 7/12. Same thing with the second exponent. As is, because the indexes are different, I can't do anything with these. So it is in my best interest to convert them. That's going to become the denominator. So 5 to the 1/3 over. This technically is a 2. Remember, when it's invisible, it's a 2. So this becomes 5 to the 1/2. Now this time, I still want to subtract these. But again, denominators need to be the same. So 1/3 minus 1/2. I'm going to go ahead and change those to a 6. So that becomes 2, that becomes 3, and end up with negative 1 over 6. So here I have 5 to the negative 1 over 6. And we do not like negative exponents in our final answer. So I am going to put it over 1 and go ahead and push it down. So that would be my final answer for this one.